Greetings. Today we're going to talk about precipitation reactions. Specifically, they are reactions that go on in a solution where they form a solid material. There are other types of reactions that go on in solution, as this diagram shows, but today we're going to look at precipitation reactions. So a precipitate is an insoluble solid. A lot of students get confused on this because when they think precipitate, they think precipitation, and precipitation is the liquid. But in chemistry, the precipitate is actually the solid part that comes out of the liquid. Their example listed here is shown in pictorial form. So here is our barium nitrate in solution, and here is our potassium chromate in solution. So potassium chromate is the yellow solution, the barium nitrate is the clear colorless solution. What actually exists in those solutions isn't the chemicals themselves, it is the ions that the chemicals or this compounds are made up of. So that's actually, when I put barium nitrate in solution, these are what are actually hanging out in that solution. When I put potassium chromate in, these entities are actually what are hanging out in that solution. So again, a pictorial representation, another pictorial representation. After you mix them together, notice we have a solid down here, but here is an actual image of what that solution would look like. Now originally when you mix that together, it's going to look like it just turned into a yellow milk type liquid, but if you let it settle, it will look like this, where all the solid will settle out. Some solutions, precipitation reactions, will give you a white solid, and that does look like milk, but over time it does settle out, and you know you actually have a solid existing in that precipitate. It doesn't stay suspended forever. Here are the solubility rules. You do need to know these. Most students think these look impossible. However, you can generally get away with learning these first three, and then you can almost determine everything else other than that. So if you know those first three, that gets you a long way in chemistry. It is important to know the others as well, but if you know those specifically, that's a good way to do that. You can go into the Canvas site and you can pull off this particular slide and print it, so you have the solubility rules. I'm pretty sure the solubility rules are in either the front or back part of your textbook. You can also just write these down. It always pays to write things down onto a note card, and then that will help you memorize them. So using those solubility rules, predict what will happen when the following pair of solutions is mixed. So again, these are aqueous. These are ionic compounds that are aqueous. That's what that AQ stands for. So what do they really look like? We really have in solution potassium ions, nitrate ions, barium ions, and then we have 2 chloride ions for each formula unit of barium chloride. So what we do is we'll put together, and in chemistry, positives go with negatives. You can't put two positives together, you can't put two negatives together. So these two were already together, so that one is not an option. But let's go ahead and put this with the other negative, and then we'll put the other positive and negative together. So notice in this, we would end up with a K mixed with a Cl, so potassium chloride, and a BaNO3. So what do we know? The first rule was all nitrate salts are soluble, so that one's not going to form a solid. And the second rule said all chloride salts were soluble except for silver, mercury, and lead, and this is not silver, mercury, or lead, so that one's not going to form a solid. So when I put these two compounds, or these two chemicals together, nothing's going to happen. So again, there's the actual, I didn't balance the chemical formulas, but there's the actual chemical formulas balanced, and then it says there's no precipitate forms when you mix those two things together. So if you saw that in lab, what you would say is you would say there's no reaction, because the things on the reactant part of your equation are going to be the same as the things on your product side, because you didn't really form anything different. Lead 2 nitrate reacts with sodium chloride in aqueous solution to form a precipitate. What is the net ionic equation for this reaction? Now, when we look at net ionic equations, we're going to look at complete ionic equations, and we're going to look at net ionic equations here in a little bit. Basically, what we're going to do is let's look down this particular these answer choices, and first let's look over here at the solids. All nitrate salts are soluble, so that one would not form a solid. Chloride salts are soluble except for silver, mercury, and lead, so this is sodium, so that one would not form a solid. And then let's go down to this last one. Again, all nitrate salts are soluble, so the only option for this is going to be this particular equation. So we could have went through a lot of work and written out lead 2 nitrate and sodium chloride and then tried to figure out all the products, but just simply by going down through and using our solubility rules, we could predict which of those would not make a solid, and that left us with one answer choice. Aqueous solutions of sodium sulfide and copper 2 chloride are mixed together. So which statement is correct? On this one, let's go ahead and say, okay, so this is one compound, this is the other compound. So the sodium's going to go with the chloride because sodium's positive and chloride's negative. And then the copper is going to go with the sulfide. So let's look at the statements. Both sodium chloride and copper sulfide will precipitate. Well, we know this one will not because that's a chloride salt. That's not silver, mercury, or lead. No precipitate will form, or only copper sulfide. So we're down to these two answer choices. Now, this is where the first three rules don't get you there. So let's go back and let's look at the sulfide rule. The sulfide rule says most sulfides are only slightly soluble with the exceptions of the cations in rule 2. So we're talking about copper. None of those are copper, so that's only slightly soluble. If it says slightly soluble, that means you will get a precipitate because it will precipitate out of solution. So on this particular question, answer choice C is the correct one. An aqueous solution of barium nitrate reacts with an aqueous solution of sodium sulfate. Identify the solid and indicate its coefficient in the balanced equation. Now first, let's go ahead and sodium's going to go with nitrate. So we know that sodium nitrate, because all nitrates are soluble, cannot be our precipitate. But we have barium sulfate. And let's slip back to our solubility rules. Most sulfate salts are soluble with the exception of barium sulfate. So let's go back to our question. So that we know that barium sulfate is going to be our answer, but we don't know which one of those it is without balancing it. So let's first write it. So barium, this gets us practice in writing our compounds. So barium nitrate plus sodium sulfate. Now we have to charge balance these. Barium is in row 2, so it's a +2. Nitrate's a polyatomic you needed to memorize. So if I crisscross, that means I'm going to end up with that. Sodium's in group 1, so it's a +1. Sulfate's a -2 because it's one of those you had to memorize. Crisscross, and I put a 2 there. And then when I balance that out, I end up, so I'm going to take my inners, put them together. So sodium nitrate and barium sulfate. Charge balance, +2, -2. We're good on that one. +1, -1. We're good on that one. But we need 2 of those. So identify the solid and its coefficient. So it's barium sulfate is our solid. The coefficient, there's nothing there, so that means there's a 1. So that particular problem gave you a lot of practice in things that you have already learned, some things you can't forget how to do. So as I mentioned before, there are several different types of equations when you're describing reactions in solutions. So you can have your formula equation, and that's what we've been using this whole time. We've been writing things like NaCl aqueous plus BaSO4, and that was actually a solid, so that's not going to be very good. But so that's our formula equation. our complete ionic equation would actually split anything that's aqueous or strong electrolytes into their component ions and then represent it that way. Our net ionic equation, what that does, it only shows the components that undergo change. So it doesn't include what we call our spectator ions. The spectator ions are just what you suspect they would be. Spectator ions don't participate, they're just watching in the reaction. So what we're going to do, we're going to practice writing this, and I'm pretty sure the next few slides will take us through step by step, so you can go through those on your own, because what we're going to do, and I'll slip through them pretty quickly, we're just going to go through the steps right here. Let's go ahead and write this equation. So aqueous potassium hydroxide, so potassium symbol is K, hydroxide is OH, is mixed with aqueous iron 3 nitrate, so I'm just going to write iron and nitrate, to form a precipitate of iron 3 hydroxide, and I'm just going to write that, plus aqueous potassium nitrate. So this is a precipitate, so that's a solid. This said aqueous, AQ, I don't know what's going on there, getting too close to the side, I guess. This one said AQ, and this one said AQ. So that means they're going to fall apart. But the first thing we need to do, need to make sure they're balanced. Potassium's a +1, hydroxide's a -1, so I don't need to do anything there. This iron, I'm told it's a +3 because of that. Nitrate's a -1. So if I crisscross, that means I need 3 nitrates. Again, it's a +3, -1, so I crisscross. And then this is a +1, -1, so we're good on that. So what we need to do is we need to balance. Go ahead and balance like we normally would. 1 potassium, 1 potassium, 1 hydroxide, 3 hydroxides. So we need to put a 3 there. Changes our potassium, but then it balances out our nitrates as well. Okay. Now we need to break apart. So that's our complete equation. Now we need to break apart into our complete ionic equation. So we're going to have 3 potassium ions plus 3 hydroxide ions. I don't know exactly. Oh, there we go. 3 hydroxide ions, and we're going to leave out the AQs here because that's just going to get crazy. Plus 3 nitrate ions. And over here, if it's solid, it stays together. And then I'm going to have 3 potassiums plus 3 nitrates. Now notice that my nitrates and my potassiums look the same on both sides. So those are what we consider spectator ions, because I have 3 potassiums on that side, 3 potassiums on that side, 3 nitrates, 3 nitrates. So my net ionic equation is going to be 3OH minus plus Fe3 plus gives me FeOH3, and then I can put an S in there for solid. Okay. It is a little bit time consuming, but it does give you practice in some of the things that you've learned before. As I mentioned, they're going to lead you through the steps here. And that completes this slideshow. Next time, we're going to talk about how we use these precipitation reactions to perform stoichiometric calculations. So we're going to tie even more of the stuff you've already learned and just add a little bit more of a concept.